Parallel lines and angle vocabulary in 5 minutes. When parallel lines, which are these two here, are cut by a transversal, which is this line here, they create 8 different angles, and many of them are equal to each other, or congruent. In math, that symbol looks like an equal sign and a similar sign combined together. So when two parallel lines are cut by this third line, transversal, it creates 4 angles that are acute. Take a look here. This is an acute angle. So is this. So is number 6 and number 8. And all of these angles are acute, or they are also congruent, which means they are the same size. And the reason for that is different. Angle 2 is equal to angle 4 because they're vertical. They share the same vertex and are opposite of each other. Angle 2 and angle 6 are also equal, but not for the reason of that, vertical. These angles are equal because if you translate angle 2 and slide it down this transversal line, you'll get angle 6. We call those corresponding angles. Angles that are in the same position, but in a different group of 4. So in this group, 2 is the upper right angle of this group of 4. And in this group of 4, 6 is also the upper right angle. The upper right angles of these two groups are congruent. If angle 6 is acute, its measure is equal to 8. And again, that's because they share a common vertex and they are opposite of each other. They're vertical. So now we've proven that 2 and 4 and 6 and 8 are all the same size. So if I told you angle 2 was 30 degrees, that means that all of these would be 30 degrees. The same is true for the obtuse angles, like angle 1. Angle 1 is obtuse, and so is angle 3. And they are equal to each other because they are vertical. Angle 1 is in the upper left, and so is angle 5. And if I translate these angles along the transversal line, they would overlap perfectly. So they are congruent. The reason why angle 1 and 5 are congruent is because they are corresponding. The reason why angle 1 and angle 3 are congruent is because they are vertical. So angles 1, 3, 5, and 7 are all congruent or equal. So if I told you angle 1 is 150, then angle 3 is 150, and angle 5 is 150, and angle 7 is 150. Now if I took these numbers away and told you that this angle over here was 60 degrees, could you tell me the other 7 angles? And the answer is you could. You could tell me this one is 60 because it is vertical to the original. You could tell me that this one is 60 because it's corresponding to the original. You could tell me this one is 60 because it is vertical to this one. But if I told you that you could only give me a reason for why this angle is 60 based on the original angle, you'd have to use a different word. The original angle is equal to this angle down here, but not because they're vertical, not because they're corresponding, because if I slide this angle up the transversal line, if I translate it up, it wouldn't overlap the original angle. So the reason why the original 60 and this new 60 are equal is because they are known as alternate, which means one on the left and one on the right, exterior angles. And exterior angles are located above and below the parallel lines. So if this angle is 60, we know this angle is 60 because they are alternate exterior angles. If the original angle I gave you was here, you could tell me that this blue 60 angle is also equal, and the reason for these two being equal is not because they're vertical, it's not because they're corresponding, and it's not because they're exterior angles, because they are in between the parallel lines. So that makes them alternate interior angles. So let's look at these visuals one last time. When parallel lines are cut by a transversal, they create 4 pairs of vertical angles, and they're all congruent. They also create 4 pairs of corresponding angles, and they are all congruent. It only creates 2 pairs of alternate interior angles, and it only creates 2 pairs of alternate exterior angles.